Hello all, we are team number 9 and our business is PMP Hiking Store. We have a good news that we are looking for a director as one of our director has left the job. So let's begin with our project. The objective of the project is to maximize the performance and minimize the cost for our business. You can see that we have 5 different departments in our business. That includes inventory, marketing, customer service, finance, and research. Each department has 4 different skill sets of employees, where the 4 represents highly skilled level, 3 represents skill level, 2 represents intermediate, and 1 represents basic skill level. These are some of the parameters that we have used, where X represents our employees, which are 20 in number. And for assigning the days, we have given 1 for Monday, 2 for Tuesday, and likewise 7 for Sunday. Here's a small table that represents our skill levels, where 4 is highly skilled, 3 is skilled, 2 is intermediate, and 1 is basic. We have 5 departments, and each department has 4 employees with these skills. So in total, we have 20 employees. In this table, we have shown the revenue generated by each employee and the wages that we pay to those employees. So revenue here defines our profit or the performance of the employee according to their skill levels. The profit and the revenue generated by highly skilled are 320 and followed by 256, 224, and 176 for the basic. And the wages, we pay highest wages to highest skilled and likewise lowest to the lowest skills. And this goes same for all the 5 departments, and the revenue and the wages are an average figure here. Here are some of the constraints. The constraint here includes each employee will work for at least 5 days a week. Second constraint is every day 3 employees will work in each department, totaling 15 employees working every day of the week. Every job type must work every day. All employees should work a full day. Employees can only work in designated departments. The store operates 7 days a week. Each job department requires 4 skill sets. So we had to have like at least 3, so we have kept 4 as our constraint in our business. And this constraint that employees can only work, all employees should work a full day. That means they cannot work partially. That means it is more of a binary type of problem. So let's begin with our maximization problem. For maximizing, this is our objective function. And these are our constraints. For first constraint, it is each employee will work for at least 5 days a week. So we have given here greater than or equal to 5 for each of the constraints. For all 20 employees, you can see here. Second constraint is every day 3 employees work in each department, totaling 15 employees working every day of the week. Here you can see for all the 20 employees working on first day, on second day, third day, fourth day, fifth day, sixth day, and seventh day, and they all equal to 15 every day. For third constraint, that is every job type must work every day. So for that, we have used a constraint where we are forcing where we are using a constraint that every department must have 3 employees working every day. So here is for the first department, out of 4 employees, 3 are working in every day. For Monday, for Tuesday, for Wednesday, for Thursday, Friday, Saturday, and Sunday. It goes the same. Here is the revenue generated by each employee, average revenue generated by each employee on the daily basis. Here you can see the average revenue generated by highly skilled people is the more, followed by the lower skills. Here we have set our solver. Here you can see the constraints. Here is our objective function. That is, we want to assign jobs to all these employees in a way that it generates maximum revenue. And we want to change the values of these. This has been done by using sum product function. And the result that we have obtained is $26,000 is the maximum revenue generated by assigning them jobs in a way that is most beneficial for the company. Here you can see the results like 3 employees are working every day in a department. And here also, they should be greater than or equal to 5. You can see they are either 5 or 6. Here is a Lingo report of the same. It shows the same figure of the maximized value. And here is a solver screenshot and the constraints that we have given to it. The next part is minimizing the problem. For that, we want to minimize the cost in the form of the salaries or the wages that we pay to each skill set. Here is the objective function for the same. And here are the constraints. The constraints are the same as in the maximization form. Here is the table of the cost that we bear in form of wages on an average basis, where highly skilled employees get the maximum, followed by the skills lower than that. The basic employees get the least. Here we set our solver table, and the solver has the same constraints, and it has given us the schedule that assigns the worker in a way that we have to bear minimum costs. And this has again been done by using sum product function. Here is the minimum cost that we have to bear in form of salaries or the wages that we have to pay. They are 12,640. And here is the same report for the Lingo. And here is our solver input, the constraints. That is all for our project, and we welcome your questions. Thank you.